Dust. Dust in the wind. Maybe not a good idea. What exactly is dust? Well, it's obvious that it's very fine material. It's also obvious that some people think dust is bad stuff. Like your mom when she was cleaning the house to rid it of any sign of dust so that guests thought the house was always that clean. I'm sure they bought it. Dust is also responsible for things like the sugar dust explosion. It's a real thing, and I'll stick the link in the description if you're interested in checking that crazy story out. But not all dust is villain. Dust is also responsible for creating fertile landscapes around the world, and we'll be talking about that in just a bit here today. It's pretty fascinating that it then becomes this interesting link between the living and the non-living. Still not something you want to inhale, though.
Topographic, guys. So now we have a rock. Right behind us, classic red bed.
So basically, rocks break down and form sand grains and clays and silts, the finer stuff like dust. And this stuff can be taken by the action of water for the larger grains and wind, primarily for this finer stuff, where it's taken airborne and it can travel far, far away. All this sediment we've been discussing can get dried out and picked up in the wind. And when this happens, it can move in several different ways. It might just creep or roll across the surface if the energy is low. But if the energy gets a little higher, then these particles can actually be lifted. And at that point, they might hop or skip across the surface. This is most common with sand-sized grains because the energy isn't quite enough to lift them very high, but just enough that they'll skip across the surface in a process known as saltation. And this process occurs just above the surface in air or water in a region we call the bedload. Even herpetologists might be familiar with this term saltation because it's used to describe the defensive behavior of snakes when they lurch forward. So what happens when the energy is enough to toss this material even higher in the atmosphere? That's when we get suspension, the process when the finer dust particles are lifted high into the atmosphere in an area known as the suspended load. And when lots of this fine dust gets lifted into the air and marches across the land, we get events like sandstorms, dust storms, haboobs, and derechos. So what is the difference between these? Well, technically, the sand, like I mentioned before, the larger grains, they can only get lifted so high. So that's more what we might call a sandstorm. And technically, dust storms is when it's higher in the atmosphere. And these events can be incredible. Lots of towers of clouds of dust just marching towards cities and communities, covering them in fine dust. These dust storms or haboobs are the result of thunderstorm outflow winds. And just check out some of these images of some recent haboobs around the world. They're pretty incredible. At this point, we might refer to this stuff as particle pollution or particulate matter. Particulate matter, or PMs, are very small particles. So they're measured in micrometers or microns. So when you hear them, they're referred to as PM1, PM2.5, PM10s. Let's get some perspective on how small we're talking. A sand grain is about 90 micrometers or microns. Human hair, if you plucked my hair out and looked at the diameter of that, you would be talking about 60 microns. So PM10s are 10 microns. That's like a sixth of the size of that hair we were just talking about. PM10s are things like dust particles, mold, and pollen. PM2.5s are even smaller. At 2.5 microns, this is stuff like combustion particles, organic compounds, and metals. Particulate matter can also include the stuff that comes along with wildfire smoke. Organic compounds, those heavy metals, sulfates, nitrates, and allergens. This process of sediment transport and deposition can also have some negative consequences for local and even faraway environments where the dust settles, and to to living creatures, including us. If you've been unfortunate enough to find yourself near a wildfire in these increasingly common wildfire seasons we're having, you might have noticed the sun. It often looks like a strange, eerie red to orangish ball in the sky during these events. And this is actually all because of the particles in the sky. And it's actually connected to the same reason why people like looking at sunsets anyway, why people flock to the beaches in Florida and take their Instagram pictures of those sunsets. It's all because of particles in the sky, and those particles in the atmosphere are actually coming from the Saharan desert, believe it or not. These particles, whether it's wildfire smoke or dust from the Saharan desert, can travel pretty far. Research by Hongbin Yu and his colleagues found this connection and studied it by measuring the dust particles coming across the ocean. They looked at the volume and the contents, and what they discovered was quite fascinating. It turns out that phosphorus in the sands, phosphorus that's left over from when this was a lake bed in the Saharan desert, that material, which is a nutrient, moves with those dust particles and rains down on the Amazon, which is making it increasingly fertile. Connected in an awesome planetary link. But some dust can be problematic. Take, for instance, the dust we recently talked about in the Owens Valley. The Owens dry lake bed became such a problem that dust was deemed toxic and caused respiratory issues for the people who lived there. Similar issues have arisen at other drying up lakes, even at the Great Salt Lake in Utah. And when we have a source of fine particulate matter and the winds kick up, it can be a deadly combination. And what about those wildfires we just talked about? Surely they cause a spike in particle pollution, right? Well, recently I showed you with my PM detector from VEVOR what happens when I'm just sitting by a campfire. What we saw is that almost instantaneously when I held the device near the campfire, the PM 2.5s and 10s spiked dramatically. Even the organic compounds spiked as well to some threatening levels. You can see at the top the air quality monitor moving towards the poor level. This VEVOR air quality monitor has been a really interesting gadget to play with, and it's relatively inexpensive. If you'd like to get one, we also have a discount code available from VEVOR. Check the description for those. As you can imagine, larger wildfires are even worse and tend to emit substantial amounts of volatile organic compounds. Recent research by Dickinson et al., published in GeoHealth, assessed the health risks of wildfire smoke and found a plethora of VOCs in that smoke from 2019 wildfires, including benzene, a known carcinogenic compound. And it's not just the smoke and byproducts from the burning of the forest itself, but also other things that might be burning and the chemicals used in putting out fires. Forever chemicals, or PFAs. Another natural source of particle pollution includes volcanic eruptions, which creates fog or volcanic smog. Fog poses threats of particle pollution that includes sulfur dioxide gas and those aerosol particles that can irritate our respiratory systems. Unfortunately, lots of activities that help build our societies tend to kick up the dust. And one that's around us all the time and might cause us to swear a lot is construction. But this could be construction of new roadways as well as housing developments, shopping malls, and even new solar farms. And one of the best demonstrations of a place where construction is particularly problematic in this way is that of Phoenix. Phoenix is one of the fastest growing U.S. cities, and with that comes along a housing boom. New houses, shopping centers, infrastructure, new roadways, they all tend to cause dust to kick up. Similarly, mining tends to kick up a lot of dust, and oftentimes it's problematic metalliferous mine dust that rains down on the towns and cities in the areas. You might be familiar with Salt Lake City's inversion problem, and a recent research study aimed to figure out what was going on and why there was such a spike in PM 2.5s. The study linked it to halogen emissions primarily and directly to the U.S. Magnesium Company, the largest magnesium producer in North America, who extracts metal from the brine of the Great Salt Lake at a plant located upwind of Salt Lake City. The dominant contributor to regional PM is ammonium nitrate, responsible for up to 70% of fine particulate mass during those inversion periods and 40% outside of the inversions. Ammonium nitrate is a secondary pollutant formed by the reaction between ammonia, nitrogen oxides, and VOCs. NOAA models demonstrated that the halogen emissions from the U.S. magnesium plant sped up the conversion of those nitrogen oxides and VOCs to ammonium nitrate PM material. Another mining-related substance that's rather common is silica, and silicosis can be a problem in the lungs of those who mine in silica dust regions, but it also can be problematic for anyone who works with silica-based products like those who cut granite. And then there's those invisible long fibers. Asbestos, the mineral dust with a fibrous component, is primarily carcinogenic if it contains amphibole fibers longer than 5 microns. Fibrous asbestiform minerals are sometimes associated with talc deposits, giving talc a bad name. I talked extensively about talc in a video where we explored what talc has to do with Vikings and tigers and makeup. I'll put the link to that in the description. Another everyday activity that tends to kick up a lot of dust, especially in arid regions, is that of off-road travel. And in the U.S. Southwest, UTV use is expanding rapidly. The market size in 2023 was estimated over $33 billion, and it is projected to grow to $77 billion or more by 2032. It's not uncommon now to see trains of UTVs plowing through the dusty desert Southwest, and there's even a long list of off-roading events now aimed specifically at zooming every type of vehicle across the desert sands. This one, by the Trail Riders of Southern Arizona, is proud of kicking up dust. They have a specific event called There Will Be Dust. Another long-lived activity that has tended to cause tremendous amounts of soil disruption are those of farming and grazing practices. The Grapes of Wrath by John Steinbeck explores the very problems associated with these poor farming practices. Every moving thing lifted the dust into the air. A walking man lifted a thin layer as high as his waist, and a wagon lifted the dust as high as the fence tops, and an automobile boiled a cloud behind it. The dust was long in settling back again. What Steinbeck is talking about is the U.S. Dust Bowl, known for its black blizzards of dust. Some blamed nature, or the continuing drought, but it was actually a man-made ecological disaster, related to the destruction of grasslands. This graphic by the Sage Grouse Initiative perfectly demonstrates the problem. If you notice the native grass species, the roots are quite deep. But look on the far right at that non-native species, typical of the planted crops of the time. Those crop roots tend to be much shallower. And so it has been shown that the seeds of the Dust Bowl were sown when farmers in the early 20th century tore out the millions of acres of hardy native grasses to plant things like wheat or corn instead during relatively wet periods. But then a historic multi-year drought followed with a heat wave that occurred around the 1930s, and the crops died, exposing the topsoil, which was dry and loose and ripe to be swept away by those strong winds. Many researchers have started asking the question recently if we are poised for yet another Dust Bowl. Even though many farmers since the 1940s have extensively irrigated their Great Plains crops, when they are watering the crops, they're taking it primarily from the Ogallala Aquifer, which makes up most of the High Plains Aquifer system, supplying water for up to 46% of irrigated land in the Great Plains states. And this has been steadily overdrawn in recent decades, with some estimates saying that the Ogallala aquifer could be 70% depleted within the next 50 years or less. As a result, the researchers pointed out that all you need is the next minor drought to come along, then you run the risk of another Dust Bowl-like event. And it's not just crop farming. Livestock grazing is also problematic here, and a great example of this is that of cashmere wool. Cashmere is made from the undercoat of cashmere goats, seen pictured on the right. But cashmere, for as exquisite and expensive as it may be, has been heavily criticized for its environmental consequences. The high demand for cashmere has caused grasslands in China and Mongolia to all but disappear. And the only solution to this seems to be not raising such large herds of cashmere goats. And it's not just the grasslands that feel these negative consequences of grazing. Deserts can, too. If you recall from our recent adventures in the Sonoran Desert, we took a look at biocrust and the damage that cattle grazing has done there. Cow patties. Signs of grazing animals. Grazing animals can do some real damage and contributions to high PM levels in areas, even a long time after the grazing is done. So not much biocrust left out here. Maybe a little bit. I see some lichens here. Pretty broken up. So there's a little bit left there, but as you can see, pretty spotty, and what we would otherwise expect would be it actually covering a lot more of the ground here. And that would lock in those sediments, keeping them from going airborne and protecting us from things like valley fever and PM pollutants. And it was in this same region where when the winds picked up, my air quality monitor showed major spikes in PMs. And our discussion of fine particles wouldn't be complete without a look at the result of combustion and industrial activities. Air quality maps clearly demonstrate that air quality tends to be lower in and around cities, especially major cities where we find a lot of factories and plants and traffic congestion. And if you're still on the fence as to the harmful effects of vehicle exhaust, watch this demo with my air quality monitor. The vehicle's turned on there, pushed me back a bit, and you can see immediately the PMs go up, as well as the organic compounds, the formaldehyde, and I had to step away for a second because that was awful, and you can see the CO2, everything spiked as a result of that. It should also be pretty obvious that the burning of coal is related to particle pollution spikes, and this research article from Harvard also shows that it's associated with double the risk of mortality than PM 2.5 from other sources. And not to ruin your party, but next time you're watching those pretty fireworks, keep in mind there are some invisible consequences of those pretty lights. Fireworks release sulfur dioxide, carbon monoxide, as well as hazardous trace elements like aluminum, manganese, cadmium, and particulate matter in those visible clouds of smoke. During festivals and holidays where fireworks are lit off, PM 2.5 levels can be up to 10 times higher than the normal background level. This research article clearly demonstrates that phenomenon, where we can see that spike in fine particle concentrations right on the evening of the U.S. Independence Day fireworks celebrations. And one last consequence of all of this is the compounding issue of ozone. Ozone, or O3, is a gas molecule made of 3 oxygen atoms. You might have heard of ozone before and might be wondering, how could that be bad? I've heard ozone is good and protects us. Well, the thing to remember is good up high, bad nearby. It turns out that the ozone closer to Earth's lower atmosphere is problematic. The precursor pollutants and gases, like those volatile organic compounds and nitrogen oxides and carbon monoxide, reacts with sunlight to form ozone. Globally, the World Health Organization sets recommended levels of max ground level ozone concentrations at 100 micrograms per meters cubed in an 8-hour average time or less. And you might be wondering where you can even find out what your local ozone levels are and if you're at risk, and there are several sources. This one that you're looking at is from the Windy app, which you can get on your phone, and they have a layer that shows your ozone as well as PM levels.
Ozone is rather harmful to our health and tends to spike on nice, calm summer days. That's why you might see ozone alerts where you're discouraged from doing activities like mowing your lawn that tends to contribute those precursor materials that end up forming more ozone.
And that means it can have some harmful consequences to our health.
A 2019 study showed that indoor and outdoor air pollution caused almost 7 million deaths globally.
So what can they do to us? Well, this can have harmful effects to our respiratory system. So it can agitate asthma, but it can even make breathing difficult for anyone depending on how bad the PMs are on that particular day, which air quality is monitored, and you can actually see your local air quality monitoring the PM 2.5s, PM 10s, sulfates, nitrates, dust mass, stuff like that, and you can monitor it. You can also get a tool for monitoring your PM. So if you're like me and you're trudging around in arid regions, you might want to go by the method of mask, monitor, and filter. You need to wear an N95 mask to keep the PMs from going into your lungs. The next thing is to monitor them. You can see even the Weather Service will put out air quality alerts, and you can see how high your PMs are for the day. If you're going to spend extended periods of time out in arid regions where you think there's a lot of dust getting kicked up or where you might be exposed to PMs, that's when I recommend getting some kind of air purification system. You can get air purifiers for larger spaces like around your home, and you can also get small portable air purifiers like this one. This is the HALE personal air purifier, and I take this with me on site. So when I'm traveling in the car or when I'm at camp in my tent area, I can actually get some purified air and get a little break from all that dust I've been breathing in and exposed to on site. Now, PMs and particle pollution don't only affect us and the living, it also affects ecosystems in which they rain down on. PMs are responsible for increasing the chance of acid rain and increasing the acidity of waters in which they fall into. It can have an over-nutrification effect on coastal and inland water environments, and it can essentially affect the diversity of these ecosystems. So, PMs can be harmful to us and the environment. All right, well, I hope you guys enjoyed today's in-depth look at dust. I told you guys I would make dust interesting, and I'm definitely not going to do that again. I learned my lesson last time. If you guys would like to join along on the next adventure here at Let's Go Geo, well, what are you waiting for? Subscribe. Join me on the next Geo field adventure in geology and geography. We have a lot more fun to have around here. You can also support the Let's Go Geo project. You can find Let's Go Geo on Patreon, as well as Instagram and Facebook if you'd like to follow along there. Either way, I'll see you guys on the next adventure.